Dear student, today's topic is projectile motion. So projectile motion is a two-dimension motion, that is the motion in a plane. So when we throw an object in the space, it goes along a curved path. Such object is called a projectile, and motion of such an object is called projectile motion. Examples of projectile motions are the path of a bullet coming out of a barrel, or the path of a shell coming out of a can. Now we take, suppose this is a coordinate system x and y. We throw an object with a speed u at an angle theta naught. With a speed u with the horizontal, the object will go along this curved path. So, G is vertically downward acceleration due to gravity, and we have assumed there is no frictional resistance, there is no resistance of atmospheric air. So, this is the horizontal component ux and this is uy. So, ux equals to u cos theta naught and uy equals to u sin theta. After time t, as the body goes up, horizontal component will remain constant because there is no force or no acceleration in the horizontal direction. But as the body goes up, the vertical component is continuously decreasing because gravity is downwards. At the highest point, vertical component will be zero. Only horizontal component will be there. After that, the direction of vertical component will be downwards. And after that, vertical component is continuously increasing, and now the after a complete path, the projectile will strike the ground with the same velocity as it was having initial velocity u. Suppose after time t, it is here with velocity v. Now this is the point p xy. So this angle is theta. This is vx. This is vx. And this is Vy. So Vx equals to V cos theta, Vy equals to V sin theta. And we know horizontal component remains constant, we will write Vx equals to Ux. So V cos theta equals to U cos theta naught. Now I draw a perpendicular here. This distance is Y and this distance is X. Now in time t, the projectile goes from O to P. Horizontal displacement is x and vertical displacement is y. As we know, there is no acceleration along horizontal direction, so we can write x equals to ux into t. Horizontal displacement equals to horizontal velocity into time, or equals to u cos theta naught into t. So t will be x upon u cos theta naught. Now, what about y? For vertical displacement, we use second equation of motion. So y equals to uyt minus rpt square. So uy means u sin theta naught t x upon u cos theta naught minus half g x upon u cos theta naught whole square. So u cancelled, to y equals to x tan theta naught minus gx square upon 2u square cos square theta naught. This equation is quadratic in x and represents a parabola. So we can say path of projectile in the absence of atmospheric resistance, when only gravity is present, the path of projectile is parabola. So this is parabola, trajectory is parabola. Now, as it is going up, at the highest point only horizontal component is there. At the highest point, vertical component is 0. This is maximum height h. Now after this time, after this point, projectile is coming down, so direction of vertical component will be reversed. So these 2 points are at the same height, so velocity will be same at these 2 points. So this is Vx theta, this is Vy. Now vertical component is continuously increasing. Here it will strike with the same velocity u, angle theta naught, ux and uy. And we say from this point to this point, this distance is r horizontal range. Now what is maximum height? For maximum height, we can write highest point, we will use the third equation of motion, 0 square equals to uy square minus 2gh, or 0 equals to u square sin square theta naught minus 2gh, because uy equals to u sin theta naught. So 2gh equals to u square sin square theta naught. So h equals to u square sin square theta naught upon g. This is the formula for maximum height. Now what about